All right, class, welcome to Math 2015 Learning Outcome 13 video. In this video, we'll go through a PowerPoint on solving word problems using bar models, where we're going to transpose unit solutions into algebraic equations, and then use that, the power of algebra, to solve the word problems. Okay, next slide. We'll go ahead and just do a few examples for this. We need to produce a bar model and a teacher solution using literal symbols instead of units. Literal symbols meaning letters, or in our case for algebra, variables. So here's a word problem. It says Peter, Ali, Ming-Fa, and Sunny share the cost of a present. Peter pays 1/6 of the bill, and the rest of the cost is shared equally by the other three friends. If Ali paid $15, how much did the present cost total? Okay, so we need to do a bar with the entire bar length signifying the cost of the present. Okay, so we'll do a bar. Okay, this is the cost of the present. Now, Peter pays 1/6 of the bill, so we need to divide this bar into 6. So I divide it in half, and each of these halves I divide into thirds. Okay, then I'm going to shade the first part, which is Peter's. And label it. Okay, so that's his portion, 1/6. Now the remainder is shared equally by the other three friends. So we have to draw another bar here that's as long as the remainder of the first bar. And we need to divide into thirds. Okay. Now there are 5 pieces left in my top bar, so the lines won't match up. So I'm just going to kind of guess as to where they would be. That's my thirds. Now Ali pays $15. I'm put my 15 in here because I'm double labeling this. This will be Ali's part. And then this part right here is going to be Ming-Fa. And this part right here is going to be Sunny. Okay. So we're going to have Ali is our $15, and that's related to part of the bar. Peter is 1/6 of the bar. So we need to find how much the present cost total. Well, we know what Ali was paying, and we know that the Ming-Fa and Sunny will also pay the same amount, $15. So we're going to let X be Peter's portion. Okay. We need to have a variable because we have X here for Peter, and then we just need to multiply it by 6 to get up to the whole present. So that's what's going to be our variable. It's kind of like our unit. One variable is like one unit. Okay, so we'll let X be Peter's portion. So we're going to set our variable to some part of our bar. That's the new thing for this learning outcome, is that we're going to use variables. Okay. Now, how am I going to relate X, or the bar, top bar, to the bottom bar? Well, we know that Ali and Ming-Fa and Sunny all pay $15. Okay, so we're going to go ahead and write 15 into each of these. And those 3 sets of 15 correspond with the 5 pieces in the 6th of the whole cost of the present. Okay, so 5x, or 5 times the same amount as Peter, is equal to the 3 sets of 15 dollars. Okay, so what we need to do to solve this is we need to say X is going to equal something, and we need to relate X with a number or something like that. So they will give you a number relationship. Okay, so 5x is equal to 3 times 15. Let's go ahead and solve it for X. 5x is equal to $45. Divide by 5. X is going to equal $9. Okay. Now, even though we found X, it's not the answer to our question. We need to see what the answer to our question is. How much did the present cost total? Which means I need to find out the length of this whole bar here, this whole thing here. And when I do that, I know that there are 6 pieces, each of which is one size, 1/6, each of which is 1x, okay? So I'm breaking down my 5x, and I need to get to 6x, build up to 6x. So go ahead and multiply by 6, okay, to get up to my 6x. Okay, so we have 6x is $54, so that means that the cost of the present is $54. Okay, so we have that as our answer. Now, we've got our bar model, question mark. I don't have my question mark on my bar model, so I'm going to put it right up here. It's the cost of the whole present, question mark. Okay, so bar model is now set. The x variable is now set. And the cost of the present now set. In this one, I'm going to count x variable and my arithmetic as separate parts because you need to have a variable here. Okay, that will be 1 point. So each one of these will be worth 4 points. Okay, we need to relate our variable to an unknown in our bar model. Okay, all right, so there's that one. Let's go on to the next one. There are 30% more black chairs in the auditorium than purple chairs. Okay, so maybe we're doing something at Weber State. Black chairs and purple chairs. If there are 460 total chairs in the auditorium, how many are purple? Now notice that this is a percent problem. Okay, when we do a percent bar model, we have our percent number line. So let's just write that in there. From 0% to 100%. Okay, so we have 30% more black chairs in the auditorium than purple chairs. So our keyword is than. Purple chairs is my whole. And if there's 30% more, okay, so let me draw in my purple chairs. Purple chairs goes up to 100%. Black chairs, I'm going to draw next. That will go up to 130%. So we need to extend our bar model because there's 30% more black chairs. Okay, so that's how many black chairs there are. Purple chairs are the top bar. In total, we have 460 chairs. Okay. Now what we need to do is we need to answer our question. How many of them are purple? If there's 460 chairs, how many of them are purple? So we have purple chairs is 100%. And the black chairs is also 130%. But both of them combined make 460 chairs. So I'm going to say, okay, the 460 chairs will be split up into some number of purple chairs and some number of black chairs. Okay, so let's let, and we don't know how many are going to be in each, so we can let, for our variables, let's let x equal the number of purple chairs. Let's let y equal the number of black chairs. Okay, we know that they add up to 460. And then we're going to add up. So we're looking for ways to relate our quantities with the variables here. We know that they're going to add up to a certain number of percent too. So if purple chairs are 100%, black chairs are 130. So we have 230%, both of them together. Now, because we need to relate our chairs 2% so that we know how many chairs there are. If there's 100% purple chairs, how many chairs does that equal? So we need to equate the percent and the chairs. So it just so happens that when I set variables equal to the number of purple chairs and black chairs, we add them together, we get 460 chairs and 230%. So our 230% can equal 460 chairs because they both equal the same thing. So they must be equal to each other. It's called the transitive property. Now, we want to break down our 230 and build up to 100 because that's a question. Okay, our question is, how many purple chairs are there? Okay, so this is our question mark. Okay. So we need 100% here. Now, we can break down to 5% or 10% or something like that. But let's just go ahead and make it a little bit easier and break down to 1% is equal to 460 divided by 230. Okay. And then I'm going to build back up to 100%. Okay, by multiplying this by 100. Okay, which means that this is equal to 200 chairs, purple chairs. Okay. All right, so that's my my bar model with my question mark. That's what you have to do to get the first point. Second point is to label your variables with something in the problem. And then the third point is your arithmetic. And the fourth point is your answer in a sentence. There are 200 purple chairs. Okay, so there's my fourth check. All right, so you guys getting the hang of the idea. The tricky part is the variable part. And so when I have some amount of purple chairs, some amount of black chairs, I let x and y be those. There may be ways where we can just use one variable. Okay, so let's go ahead and try another one. And I'll try and focus on the variable part. The cost of 6 mangoes was the same as the cost of 2 durians. Paul bought 3 mangoes and 4 durians for $30. Find the cost of 1 mango. The cost of 6 mangoes was the same as 2 durians. Okay, so I need to draw a bar with mangoes and then show that there are 6 of them relating to 2 durians. Okay. So number of mangoes. Is going to be shown in a bar. The cost of 6 mangoes was the same as the 2 durians. Okay. 6 mangoes. So I take my bar, number of durians. Okay. And if there's 6 mangoes to every 2 durians, That's the same as a 6 mangoes to 2 durians. 6 mangoes. We want 3 mangoes though. Okay. So let's divide this one into 3. Now, if I wanted to buy 6 mangoes and 2 durians, it would be twice this amount for mangoes. Okay. So I'm going to try and draw one in dashed lines. Okay, even though I'm not using them, there's 6 mangoes there. 1, 2, 4, 5, 6. Okay, that should be the same cost as 2 durians. So there's 1 there, 2. Okay. All right. So those will help me keep track. So 3 mangoes is the same as 1 durian. Okay, so that's what a 6-to-2 relationship has. Now, there are 6. Oh, and Paul bought 3 mangoes, so the number of mangoes is already depicted, and 4 durians for $30. So that we need a couple more durians in here. And all of this is going to be $30. Find the cost of 1 mango. So my question mark is up here. Okay. We need to write our relationship into a variable, the thing that we're going to find. So cost of 1 mango, well, that's going to be what we're going to find. So let's set that as to x. Does x equal the cost of 1 mango? Okay, and what do we know about the money and the number of mangoes? So we need to know how much 1 mango costs. So $30 equals, x is 1 cost of mango. So $30 is the same as three mangoes here, 3 mangoes here, 3 mangoes there, 3 mangoes there. So how many mangoes do we have? All of them together are $30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, there are 15 mangoes. Let x be the cost of 1 mango because that's what we want to find. So that's a good way to show your variable. Pick out your variable. Look at what you're going to set it equal to what you want to find. We did learn that there are 15 x's there, the same as $30. Okay. And the cost of 1 mango, that's what we're going to find is x anyway. So if we divide by 15, x is going to equal $2. And that's what each mango will cost. So write our answer in a sentence. Okay, notice that let x be the cost of 1 mango, which means it's a number. Okay. We have these numbers. So here I have my bar model with a question mark. My x is a variable associated with some aspect of my problem, my arithmetic, and my answer in a sentence. So 4 points there. Okay, that was all for Learning Outcome 13. And we'll go ahead and stop here, and we'll take a break for Learning Outcome 14. In this part of the video, I'm going to go over a couple of homework problems to help you get going with that, because there's only a few examples in the regular PowerPoint video. Learning Outcome 13 homework starts with number 33 on the Unit 3 homework PDF. And 33 says for number 1, 9, 10, 20, 25, 29, and 32, transpose your unit solution by using a literal symbol in place of unit in your solution, and state what the symbol stands for in the problem. So for example, I'm going to do number 20. And you can see I'll do it with the regular way from learning outcome 11, 12. And then I'll do it the 13 way when you transpose to use a literal symbol or a variable for your unit solution. Now going to number 20. Okay, so we have learning outcome 13. Number 33 with number 20. Okay. So going to number 20, it says that, sorry, no, it wasn't 20, it was 25, sorry. 25. It says that 3 boys share a sum of money in the ratio of 5 to 3 to 2. The smallest share is $30. Find the biggest share. Okay, so this is going to be the learning outcome. Okay, so that's my title there. Learning outcome 11 and 12 way. So we have a ratio, which is 5 to 3 to 2. So when we do the ratios, we have like these 3 boys. So we have boy 1 has a portion that's 5 units. Okay, so there's 5 units there. Boy number 2 has a portion that's 3 units. And boy number 3 has a portion that's 2 units. Okay, so all 3 boys' portion is depicted in this bar model. The smallest share is $30. Okay, so that's $30 right here. And we're going to find the biggest share. So that's this one right here, the 5 unit one. So that's our question mark. Now, with the learning outcome 11 and 12, we needed to do bar model. And then we needed to do arithmetic. And then answer in a sentence. Okay, so the arithmetic is that $30 represents 2 units. Okay, we need to know what 5 units are because that's how much the boy 1's share is. So we're going to break down our 2 units into 1 unit, and then we're going to build up to 5 units. So 1 unit is equal to $15. Okay, then we're going to build up to 5. So I divide by 2. $30 divided by 2 is $15. Then, and 2 units divided by 2 is 1 unit. Build up to 5 units by using multiplication. 1 times 5 is 5. Okay, so breaking down by dividing by 2, building up by multiplying by 5. And then $15 times 5. Well, 15 times 2 is 30, plus 3 is 45, plus 4 is 60, plus 5 will be $75. Okay. So in learning outcome 11-12, we have our answer in our sentence, which is the answer to the question, find the biggest share. The biggest share is $75. Okay. So I have all 3 parts. So we have a bar model, arithmetic, and we have the answer in complete sentence. Now we're going to translate this to learning outcome 13 way. Now, learning outcome 13 way is replacing the unit with a variable. Okay. Now we can use a couple of different ways, but usually we go for a unit or the thing that we're looking for. Now the biggest share I can't set as x because it's like 5 parts. We can set x to be the unit part. Okay, that will be right here. Okay, so that's kind of what the directions are saying anyway. Set x to this unit amount. So what you do is that we have our diagram here already, and so we're just going to go ahead and do the arithmetic, and the sentence will still be the same. So the arithmetic part, let x equal 1 unit, which is 1 one part of a share of money. Okay. We need to explain what that 1 unit is. And that's my explanation. So there's a couple points here. Then we go ahead and say, okay, 2 units, or 2x, was equal to $30. That means that x is going to equal to $15. And the largest share is 5x. 5x will be $75. Okay. And so that's as much as we need to go for this one on learning outcome number 13. Okay. So we let x equal 1 unit, that's 1 point there. And then we need to say what it is, that's another point there. Okay, so this answer will be 2 points. The next one that I wanted to do was into the homework. 34 has several parts to it, so we just let x equal, we just take do the whole bar model from start to finish with it. So it looks like we can do, let's try 34b. 34b. Okay, the ratio of last year's attendees to something is to this year attendees to something is 3 to 2. If 3,450 students attended last year, how many less people will attend this year? So my ratio was 3 to 2 of last year's attendees and this year's attendees. So last year's attendees are related to 3 units. Let's try to make this part a bit better. Okay, 3 units. Okay, that's last year's attendees. And it says in the problem that that is 3,450 students. This year's attendees is the second part. It's two units. Okay. And the question is asking us how many less students attended this year than last year. So here's our difference as a question mark. And we don't know how much that is. Now, going down to the unit level is what we usually do for when we say that we're going to find our answer. We go to unit. 1 unit is equal to that, because we have 3 units equals to 3,450. But in this learning outcome, we're going to relate the units to a variable. Okay. Now, x is going to be my variable, and it's going to not equal attendees. It's going to equal a number of attendees. Okay. Now, what I'm finding is x. So how about if we let x be the question mark? And it will work on this one. Just set x equal to the question mark. So let x equal the number of less students attending this year. Okay. That's what we're looking for. That's our unit level anyway. All right, so we have our x equal to something, and then we're going to have to show some arithmetic. The only thing that we have for your units and relating to number of students is the last year's attendees, where 3x was equal to 3,450 students. So when we want to solve for x to know the number of people less attending this year, we divide by 3. 3,450 divided by 3. Well, let's take it digit by digit. So 3,000 divided by 3 is 1,000. The 400 divided by 3, well, there's one of those, 100 for each of those, but then there's going to be one left over. We put that 1 with the 5, make it 15. And so 15 tens divided by 3 is 5 tens, and the 0 divided by 3 is just 0. Okay. So 3x is 3,450 students, then x is 1,150 students. Okay. So then our answer in a sentence is there were 1,150 students, less students, change this to less students attending this year. Okay, so I have my bar model with my question mark. My x equal to something. I need to say what my variable is equal to with respect to the context or the part of the problem. I have my arithmetic and my answer in a sentence. So 4 points there.